Air conditioning. Make it cool when it's hot, make it warm when it's cold. It doesn't make any difference what the temperature of the outside world may be. Thanks to the advancements made by the Chrysler engineers, people can drive around in the type of comfort which suits them best. Chrysler Corporation Air Conditioning for 1974. The big news for this year is the Blend air conditioning system for the top-of-the-line cars, Chrysler, Dodge Monaco, and Plymouth Fury. Blend Air. It's a system which allows the driver to select the temperature of air to be as cool or as warm as they desire it to be. Cold enough for a fur coat, or comfortable enough to wear a bikini. And then, of course, there's the Auto Temp 2 Blend Air system, standard in Imperial and optional for the rest of the full-size car lineup. The temperature level is pre-selected by sliding a lever to the degree of comfort desired. It's then automatically controlled to stay at that level, regardless of any temperature variation outside the car. Outlet air temperature is varied by positioning a Blend Air door to regulate the amount of refrigerated air flowing through or bypassing the heater core. In manual air conditioning, the instrument panel push-button controls and slide lever regulate the positioning of the airflow doors in the air conditioning housing. When the max AC button is pushed, the inlet air door moves up to seal off outside air. The system recirculates the air inside the car in the max AC mode. Sliding the temperature lever to cool moves the Blend Air door into position to prevent air from circulating through the heater core to assure maximum cooling. Actually, the heater core is cold at this time. The water valve is closed when the push button is in the off or max AC position. The mode door moves to close off the heater defroster chamber. The blower control lever provides a choice of 4 blower fan speeds. Okay, here's an X-ray view of the airflow. The blower draws air through the inlet, which is in the inside air position, and forces it through the evaporator coil. The Blend Air door is positioned so the air is diverted to the air conditioning outlet without passing through the heater core. The defroster door is in the up position. The mode door is open in air conditioning position, eliminating any air from going into its heater defroster chamber. Now, let's say we go from max AC to AC. The inlet air door moves down to open a path for outside air to be drawn in through the plenum chamber into the blower. The blower forces the air through the evaporator coil towards the Blend Air door. The air conditioning heat door, also known as the mode door, is positioned to direct the flow of air through the air conditioning outlets. The water valve opens, allowing full flow through the heater core. The heater core is always hot when the control unit is in any position other than max AC or off, and outlet air temperature is regulated by the positioning of the Blend Air door. Now, let's put the control unit in the vent position. The inlet door is open to outside air. The blower forces the air through the evaporator. However, the evaporator does not cool the air because the compressor clutch is disengaged when the vent button is pushed. The air moves to the Blend Air door and the mode door. The heater core is hot at this time because the water valve is in the open position. It's possible to have heated outside air ventilation because the Blend Air door can be positioned to direct as little or as much of the outside air through the heater core until a comfortable temperature is reached. The mode door is in the air conditioning mode, so the vent air is directed through the air conditioning outlets. In the heat position, the mode door moves from the air conditioning position to the heat position. Airflow is directed through the heater and defroster portion of the unit instead of the air conditioning outlets. Notice the heater defroster door is in the up position. The majority of the air is directed through the heater outlets, and a small amount of heated air is directed to the defroster outlets. In the heat position, the inlet door is opened to outside air. The compressor clutch will be disengaged, so the air blown through the evaporator coils will not be cooled. When the defrost button is pushed, the only door that moves is the heater defroster door. It swings down to direct most of the heated air to the defroster outlets. So much for airflow. Vacuum feed for the air conditioning system is from the engine intake manifold through a check valve. It's necessary to know the correct position of each door for each push-button position when you're testing the doors in the distribution system. This information is covered in detail in the reference book. Also, the electrical portion is too complex to be covered at this time. See the reference book for a diagram of the electrical circuit. Now let's get into the 1974 AutoTemp 2 system. The AutoTemp system automatically controls the air conditioning and heating system to maintain a selected comfort level in the car. The driver controls consist of 6 push buttons: off, vent, 2 for automatic, and 2 for defrost. The operator selects any interior comfort setting between 65 and 85 by moving a lever. The heating, cooling, and air distribution sections are practically the same in arrangement and function as those used in the manual control air conditioning installation. One of the differences immediately noticeable is the blower speed selector switch used with manual control air conditioning has been omitted on AutoTemp. Blower speeds are controlled automatically. Let's begin at the beginning and cover the components and their functions individually. First, there's the air conditioner housings, which contain the evaporator, heater core, blower motor, and air distribution doors. The push-button control unit starts the action when the operator selects one of the AutoTemp modes. Temperature is selected by moving the slide lever to the comfort range desired. This amplifier is a solid-state device which operates like a small computer. It receives input signals from the push-button control switch and the temperature sensors. The in-car sensor measures the inside temperature, and the outside or ambient sensor measures the outside air temperature. They send electrical signals to the amplifier. The servo receives signals from the amplifier to control outlet temperatures and perform electrical and vacuum switching. Here's an example of how the AutoTemp system works. Ms. Comfy Cozy is driving to the store to spend her husband's hard-earned money. It's a warm day, say 85 degrees. Ms. Cozy finds she's very comfortable when the temperature is around 75 degrees. So she pushes the low auto button and slides the comfort lever to 75. The amplifier receives the input signal from the push-button control unit and goes into action. The request is for a comfort level of 75. The amplifier needs information from the temperature sensors before it can signal the servo. What is the temperature outside the car? 85 degrees. What's the temperature inside the car? 79 degrees. The amplifier evaluates the signals from the sensors and combines them into a single signal, which is sent to the servo assembly. The servo motor is linked to the blend air door in the air conditioner housing and is started, stopped, and reversed by the electrical signals from the amplifier. When the motor receives the signal and begins to turn, it moves the blend air door to make temperature corrections. A rotary vacuum switch turns to direct vacuum to operate the vacuum units. An electrical contact arm moves over a printed circuit board to change blower speeds. It also provides the electrical connections for the park feature, which we'll get into later. The servo also has a feedback potentiometer, which sends an electrical signal to the amplifier to tell it when it has reached the proper position. It also has a relay switch, which activates the high blower relay when the AutoTemp system is in the high defroster or high auto position, and maximum heating or cooling is required. So here's what happens. The operator moves the comfort lever in the control unit to the desired level and pushes the low auto button. The amplifier receives the signal from the comfort lever potentiometer. The outside air temperature sensor and inside air temperature sensor send an information signal to the amplifier. The amplifier sends a signal to the servo assembly to go into action. The electric motor in the servo is energized and begins moving the blend air door in the air conditioning housing. The blend air door regulates the amount of air flowing through or bypassing the heater core. The inside air temperature sensor constantly measures the temperature of the air inside the car. When the inside air temperature reaches the comfort level selected by the operator, the in-car sensor signals the amplifier to stop the servo and keep the blend air door in that position. If the outside air temperature remains constant, say 85 degrees, the auto temp system senses that all the components are adjusted to deliver inside air, which is approximately 75 degrees. Okay, let's say the air temperature outside the car drops to 82 degrees. The sensor picks up the change and sends an electrical signal to the amplifier. The amplifier picks up the signal that the temperature outside the car is dropping and energizes the servo motor to move the blend air door and allow more airflow through the heater core. The feedback potentiometer signals the amplifier to turn off the servo motor when it has reached the proper position. When the high auto position is selected, the unit operates the same as in low auto, except that it has only 4 blower speeds for air conditioning and 3 speeds available for heat. All blower speeds in the high auto are slightly higher than in the low auto position. See the reference book for a more complete explanation of blower functions. In the vent position, the system will be in AC mode with the compressor clutch disengaged. In the low defrost, the system comes on immediately with air coming out of the defroster outlets with a bleed to the heater floor outlets. 3 blower speeds are available for air conditioning and 2 speeds are available for heating. The outside air door is located in the 20% or the 100% outside air position, depending on the position of the rotary vacuum switch. In high defrost, the system comes on immediately with air coming out of the defroster outlets with a bleed to the heater floor outlets. The high defrost circuit bypasses the sensors and control potentiometer and signals the amplifier to direct the servo assembly to full heat at the highest heat blower speed. The outside air door is located in the 100% outside air position. The compressor operates if the ambient temperature is above 32 degrees. When the off button is pushed or the ignition is turned off, the amplifier receives the signal to put the system in the park position. The servo parks in low or M1 blower after AC operation and low blower after heat operation. The outside air door is closed and the blower motor and compressor will not operate. This prevents a sudden blast of hot or cold air when the car is restarted or when the unit is put into one of the other modes. Well, with our unit in park position, it would be a good time to bring this session to a close. Time is running a little short. You'll have to see the reference book for the rest of the 1974 AutoTemp 2 story. By the way, the previous version of the AutoTemp 2 system was covered in the 71-4 Master Technician Service Conference session. For your information, you may want to compare the early version with the 1974 AutoTemp 2 system. And for the full servicing story, see the 1974 Service Manual. The next Master Technician session will cover changes in the compact car air conditioning system and refrigeration for 1974. Also, it will serve as a review and as an introduction to testing and servicing procedures, which include the new H-type expansion valve and such innovations as liquid charging. See you next month.